All right, so let's start with the basics, right? What is a computer? Um, and we work with computers, we see them, we interact with them, we carry them in our phones, and so on and so forth. But what is a computer? Let me give you a sort of may sound meaningless definition, but a starting point, right? Computer is a thing that manipulates other things. All right, so manipulates as in performing things like addition, subtraction, comparison, that sort of thing. But what kinds of things does a computer manipulate? I'm going to start with just plain old numbers. So, here's a number 23. That's a thing that a computer can interact with and manipulate. Here's another thing, 17. And maybe what the computer is going to do at this particular moment is add these together and come up with the number 40. Right? And at some level, that's what computers do, right? All day long, cycle after cycle, they're taking objects and manipulating them. So reading, modifying, writing, that kind of thing. All right, let's talk about the objects that are being manipulated. Numbers, for example, but it doesn't have to just be a number like a quantity, right? It could be a number that represents the position of a gear in a machine. It could be a number that represents the volume of a piece of sound coming out of a speaker, or the brightness of an individual pixel in one frame of a movie, right? So we can represent a lot of different things with numbers, but at the lowest level, the computer is just manipulating numbers, right? So these are our objects, our things that are being manipulated, what we can think of as data. And then what kinds of operations or manipulations does a computer do on data? Well, it can do arithmetic like add, subtract, multiply, divide. It could do comparisons. It could do logic operations like say, is this thing the same as this other thing? It can do other kinds of comparisons, which of these two things is bigger, and so on and so forth. So we can think of these as code or operations, right? So those are things that we are doing to our data. We can also think of our data as operands. And so the operations manipulate the operands. All right, that's a really simple view of what goes on in a computer. So the next question is, how does a computer know what to do? How does it know that right now it should take these two numbers and add them together? And so we need some way of storing a set of instructions. And we do something incredibly useful, which is we store the instructions using more numbers. So numbers represent the things that are being manipulated, but they also represent the instructions, the operations, the code that says, what should I be manipulating? All right, so we're going to have lots of numbers in our computer. How are we going to access these numbers? Well, we have a notion of a memory. And we put our numbers into our memory. There's our 23 and our 17 and our 45 and our -6 and so on. Since we have multiple numbers stored in our memory, we need a way to access each of those. And so we have an address, which is just another number. And maybe at address 0 we have 23, at address 1 we have 17, and so on. Alright, so what do we got here? We've got a memory with a bunch of numbers stored. We can access those numbers by using the address of each number, which is another number. And we can also get operations which say, hey, I want to add, I want to compare, and so on and so forth. And those instructions are also stored in the memory. Right? So this is an interesting model. We have a computer memory which stores data and also stores code, right? And that's the real power of the way computers have been designed for almost 100 years now, is this idea of storing your program in the same place that you store the data that the program operates on. All right, so that's kind of an abstract view of what's going on in a computer. Let's take a look at this on the Touch Metal board. All right, so this is the Touch Metal board that I've developed. It's a little custom 8-bit microprocessor. Has a couple of hundred memory locations into which we can store and retrieve different numbers, and then we can treat those numbers as instructions and execute them. So you enter your numbers using these buttons. You notice they only go up to 7. That's using something called octal. We'll talk about that later. But right now, basically, we can look at a memory location like 000 here in brackets and see what its contents is, which is 000. So let me go ahead and change the lighting here to make the display a little sharper, and we'll lose some of the visibility on the buttons over here, but a little easier to read the display. So let's say I want to store the number 23, and then the number 17, and then the number 45, right? So I can type in a 0, examine, and I see that, you know, memory location 0 has a 0. I can type 23 and say deposit, and that'll store a 23 at location 0. And then it automatically advances to location 1, which currently has a 0. So I can type 017, and I can say deposit, and that'll store a 17. And then if I want to store the number 45, I can say 045 and say deposit. Okay, so I claim I've just stored those 3 numbers into those first 3 locations in memory. Let's see if we can retrieve them. So I'll put a 000 and say examine. There's the 23. Now if I hit examine again, it'll automatically go ahead to the next location. There's our 17, and if I hit examine again, there's our 45. And then all these other locations have zeros because by default, when you first apply power, all the memory is set to 0. Alright, so we can store numbers, we can retrieve them. And those could be, you know, pieces of data that we're going to manipulate. But if we go back to that first location, 000, and examine it, you notice it also says div R1, R7. 023 is the coded instruction, which means I want you to do a division operation. So 23 could be a number, or it could be an instruction saying to manipulate other things in the memory of this machine. And if you look on the back of this, it's got a handy coding chart, and you can see right here 023, that's a divide instruction. So so that's the first aspect of this Touch Metal board. We have the ability to store numbers in memory and go back and look at them, retrieve them, and examine them. But we can also execute those numbers as if they were instructions. So if I hit this reset button, which says go back to location 0, and I say step, it will execute that first instruction, which said divide. And now it's at this instruction 45, and it doesn't have any meaning. So it's basically a no-op. We can say go ahead and do that, and then there's a 00, which is a no-op, NOP, and as I keep stepping, it's not doing anything except looking at the next instruction in memory to decide what to do. And if I hit this run button, you'll see it just keeps pulling instructions out of memory. They say don't do anything, and then it just goes on to the next instruction. And it'll keep doing this. Now you may notice it's counting in a funny way. It gets up to 177 and then it jumps to 200. That's that octal business. So when we count in octal, the biggest digit we have is 7. So when we get to 7, we jump up to 10. We'll break that down in another video. And then when we get up to 377, that's the last memory location, it rolls over back to 0. So we've got a program running, it's just not doing anything terribly interesting. But that's basically where we can start our development of how we program a machine like this.